Alright, ladies and gentlemen, today we're going to talk about section 1.6, which is multiplying and dividing real numbers. So we're going to take a lot of the things that we talked about with fractions and whatnot last time with section 1.5, adding and subtracting real numbers, except this time we're going to apply it to multiplying and dividing real numbers. So first we're going to find the product of real numbers, and we're also going to talk about simplifying square roots, as well as dividing real numbers as well. So let's quickly go over some things that you've probably talked about before. If I have a positive number multiplied by a negative number, my answer is always going to be negative. If I have a positive number multiplied by a positive number, my answer is always going to be positive. What about a negative times a negative? What's negative 3 times negative 5? Well, a negative times a negative is always going to be positive. A positive divided by a negative works the same way. Anytime you have one negative, one positive, it's going to be negative. Two positives divided by each other, or a positive divided by a positive, is going to be positive, and a negative divided by a negative is also going to be positive. So, note here's a little shortcut, so you don't have to refer back to this all the time. An even number of negatives is always going to be positive. So notice here I have a negative divided by a negative. There's 2, it's an even number. It's going to be positive. An odd number of negatives, so look here, there's an odd number, there's one negative and one negative here. Anytime you only have one negative, it's going to be, your final answer is going to be negative. Okay, so let's do some problems here. We're finding each product. Well, what's negative 5 times 8? Well, take the negative out for a second and just think back to when you learned how to multiply. And what is 5 times 8? Well, 5 times 8 is going to give me 40. But I know I have a negative times a positive, so it's going to be negative 40. Alright, what about here? I have negative 6 times a negative 17. Well, let's leave the negatives out for a second. Okay, and let's just do 17 times 6. Okay, 6 times 7 is 42, so we write the 2, carry the 4. 6 times 1 is 6, plus 4 is 10, so it's 102. Now, is it going to be negative or positive? I have a negative times a negative. I have an even number of negatives, so my answer is going to stay positive. Alright, what do I got here? I got negative 7 times 3.5. Alright, well, if I have negative 7 times 3.5, you know, one thing that I want to talk about here is what we should do is let's move this decimal over. You know, I don't like decimals. So what we're going to do is we're going to give us a problem that we're familiar with. So let's change this right now to negative 7 times 35. We'll move the decimal over once. Okay, so again, let's take the negative out for a second, but don't forget about it. It's going to come back. If I do 35 times 7, what do I get? Well, 7 times 5 is 35. Write the 5, carry the 3. 7 times 3 is 21, plus 3 is 24. So I have 245, but now I only had one negative, so a negative times a positive is negative, so really I have negative 245. Okay, but remember, I moved the decimal over once. So if decimal is moved once, so if decimal is moved once, then move decimal once back in answer. So move decimal in answer. So my answer is not negative 245. I have to move the decimal back one, so my answer is actually going to be negative 24.5. Alright, let's talk a little fractions here. I have 8 times negative 1/6. Okay. Now, anytime you have fractions, there's a couple rules. Number 1, try to cancel first if possible. Okay, try to cancel first, and we'll talk about that more in a little bit. Try to cancel first. Number 2, this is a biggie right here. Always reduce. Always reduce. And third, if you have a fraction, you can leave it improper. Okay? Leave the fraction as an improper fraction. Alright, so 8 times negative 1/6. Okay, well, what can we do? Anytime you have a number on the outside like this, if you're multiplying a whole number by the fraction, okay, you can really put this as an 8 over 1. Okay, so really, another way to write this would be 8 over 1 times negative 1 over 6. Now, when it says try to cancel first, that means since multiplying is different than adding, okay, remember with adding we had to get a common denominator. That is not true with multiplying. With multiplying, we can cancel out the fraction, or we can reduce on both sides. So I can't reduce 8 over 1 necessarily, but I can reduce the 8 and the 6. Both are divisible by 2. So I can make that a 4, and I can make this a 3. So really we have 4 over 1 times 4 over 1 times negative 1 over 3. So what I just did is I cross-reduced. So when you're multiplying, you don't only have to reduce right here. You can reduce with these two and these two as well. So I have 4 over 1 times negative 1 over 3. And now with multiplying, you can just multiply the fraction across. Okay, you do not have to get a common denominator. So 4 times negative 1 is going to give me negative 4, and 1 times 3 is going to give me 3. So my answer to number 4 is negative 4/3. Okay? Alright, what about number 5 here? I have negative 3/5 times 7/12. Well, again, let's see, is there any way we can reduce this at all? Can I reduce? Well, what I can do is, I can't reduce the 3/5 or the 3 over 5 or the 7 over 12, but I can reduce the 3 and the 12. I can reduce this, since they're both divisible by 3, I can make that a 1, and I can make this a 4. So now when I multiply across, I'd get negative 1 times 7 is negative 7, and 5 times 4 is 20. So I have negative 7 over 20. Alright, let's look at these fractions here. 2/3 times 3/8. Can I reduce 2/3 at all? No. I can't reduce 3/8 either, but let's see if we can cross-reduce. Okay, can I reduce 2 and 8? Well, they're both divisible by 2. So 2 divided by 2 is 1, and 8 divided by 2 is 4. Alright, what about the 3 and the 3? What's 3 divided by 3? 3 over 3 can reduce to 1 and 1. So really, I have 1 times 1 over 1 times 4. So 1 times 1 is 1, and 1 times 4 is 4. So my answer is just 1/4. Alright, let's get into some square roots now. The square root of 100, okay, the square root of 100 is going to be, what does that mean? It means what times what gives me 100. Okay, well, 10 times 10 gives me 100. So 10 times 10, because 10 times 10 equals 100, that means the square root of 100 is 10. Alright, now, one other thing before we move on is, think about this. Is there any other number that if I multiply it by itself I get 100? 10 times 10 works, but what also works is negative 10 times negative 10. Since we just talked about up there that a negative times a negative is a positive, negative 10 times negative 10 gives me 100 as well. So when we ask for the square root of 100, it's really, we say plus or minus 10, because it could be positive 10, because positive 10 times positive 10 is 100, or it could be negative 10, because negative 10 times negative 10 is also 100. So it would really be plus or minus 10. Now, what about if we have the square root of a fraction? The square root of 4/25. Well, here's a little shortcut. If I have the square root of 4 over 25, you can turn it into this. Put a square root on top and a square root on bottom. So I have the square root of 4 over the square root of 25. Okay, well, the square root of 4, what times what gives me 4? That's 2. And the square root of 25, what times what gives me 25? Well, that's going to be 5. And again, like over here, 2/5 times 2/5 is going to give me 4 over 25, but also negative 2/5 times negative 2/5 would give me 4 over 25, so we have to make this plus or minus 2/5. Alright, now let's get into the kind of the tricky one here. If you have the square root of a decimal, we have this plus or minus the square root of 1.21. Okay, well, you know what, that's a tough one to do in your head. I don't even think I could do that. So let's make this into a problem that we can actually figure out. Okay? Here I have plus or minus the square root of 1.21. What happens if I move the decimal over twice? So instead I change this to plus or minus 121. Okay, well, 121 is a perfect square. Okay, one of the things that you're probably going to want to know in algebra is, what are the perfect squares? We have 4, we have 9, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121. So the square root of 121 is 11. Okay, now, since we moved the decimal over twice, okay, normally you'd be thinking, well, let's move it back twice. However, if you're taking the square root of a decimal, okay, anytime it's underneath the square root, our rules change a little bit. Okay, our rules go from once in, once out, like we did up in the previous problem, to twice out, once in for decimals. Okay, so I moved the decimal out twice before the square root, then I took the square root and I got 11, so now I have to move it once back in. So my answer is actually plus or minus 1.1. Alright, this is tricky, so remember this rule. Anytime you're dealing with square roots, if you move the decimal over, or move the decimal out twice in the square root, like we did here, and then take the square root, then we move it once back in. Okay, so square roots have a special rule there, so remember that. Okay, now what about here? We have a negative on the outside. Okay, so negative square root of 36 over 49. Well, we can do kind of like what we did in number 9. Let's split it up. The negative square root of 36 over the square root of 49. So you can make it the square root of 36 over the square root of 49, which is equals the square root of 36. There's a perfect square right there. That's going to be 6. And the square root of 49, there's another perfect square. What times what gives me 49? My answer is 7. Okay, now I can't forget this negative. Now this one is not plus or minus. It's only negative 6 over 7 because it tells us that from the beginning that the answer has to be negative. Okay, if we're taking the negative square root of 36 over 49, well then our answer has to be negative as well. Okay. Alright, so now let's get into some division here. Anytime you see the word quotient, okay, it's talking about division. You're dividing things. So in this case, I have negative 24 divided by 8. Okay, so negative 24 divided by 8 is going to be, or 24 divided by 8 would be 3, and since I have a negative here and a positive there, it's going to be negative 3. Same thing here, I have negative 70 divided by negative 2. So a negative divided by a negative is going to give me a positive. So that's going to be 35. Now, I want you to pay very close attention, okay, to both number 14 and 15. Because how we solve 14 and 15 greatly depends on where the number with the decimal is. If I'm doing 7.2 divided by 8, how I move the decimal is going to be a little different than if I do 16 divided by 0.4. Here the decimal is our first number. Here the decimal is the second number. Okay, and how you do the problem is a little bit different for each one. Okay, if the decimal is the first number, like it is here, 7.2 divided by 8, we're going to do what we're used to. I'm going to move the decimal out once. So I have 72 divided by 8, okay, and that's going to give me 9. But again, if I move the decimal out once, I have to move it back in my answer. So my answer is going to be 0.9. Now, pay close attention as to how this one differs. If I do 16, okay, divided by negative 0.4, right, I'm going to do this problem a little bit differently. If the decimal is the second number, you treat the problem a little bit differently. What I'm going to do is I'm going to move the decimal from the beginning. So I have 16, okay, divided by 0.4. Okay, whoops, hold on, let me erase this here. There we go. Okay, I have 16 divided by 0.4. Sorry, negative 0.4. Okay, so what I'm going to do is I want to turn this into a whole number to make this a little bit easier on myself. So I'm going to move the decimal over here. Okay, but what I also want to do is if I move the decimal over on this guy, I'm also going to move the decimal over on this guy as well. So this is going to turn from 0.4 to, keep my division sign, I'm moving the decimal from 0.4 here, so that's going to turn into just 4. Okay? And this one is going to turn from 16, and I'm moving the decimal over this way as well, so I'm adding an extra 0 to 160. So here I have 160 divided by 4, because I'm moving the decimal over here and here. Now, since I moved the decimal over on both of them, okay, I don't have to move the decimal back at the end. The only reason I had to do that over here is because I only moved it on one. But if the decimal is second, like it is here, you have to move it over here and here. So now I have 160 divided by 4. I'm sorry, negative 4. This should be a negative. But we'll add in the negative at the end because we know our answer has to be negative because we only have one negative here. Okay, so 4 goes into 16 how many times? 4 times. 4 times 4 is 16. 16 minus 16 is 0. 4 can't go into 0. And there's a 0 here, so what do? I have to bring that 0, whoops, I have to bring that 0 up here. So my answer is going to be 40. And then again, it has to be negative because I have that negative sign there. So my answer is going to be negative 40. Okay, so if you have to rewind this video and watch those two examples again, please do it. But know the difference between solving a problem where the decimal number is after the division sign as opposed to solving a number where the decimal is before the division sign. Alright, so one thing that should help you a lot is this next sentence here. If you dividing by a fraction is the same as multiplying by the reciprocal. Okay? Now what does the word reciprocal mean? The word reciprocal means you flip the fraction. So the reciprocal of 2/3 would be 3/2. The reciprocal of negative 7/6 would be negative 6/7. Okay? So if I'm doing 4/9 divided by negative 7/18, one way to write that is like this. 4/9 divided by negative 7/18. And I don't know about you, but that kind of looks like a mess. So let's write it in a way that helps us visualize it better. I could also write this as 4/9, or 4/9, and like I said, dividing by a fraction, which is what I'm doing here, is the same as multiplying by the reciprocal. So 4/9 times the reciprocal of negative 7/18, which would be negative 18/7. Okay, so now we can do what we did on the first page and reduce this. Okay, I can't reduce 4/9 at all, or 18/7, but I can cross-reduce, because negative 18 divided by 9 is negative 2, and 9 divided by 9 is 1, so I can reduce it like that. So when I multiply across, I get 4 times negative 2 is negative 8, and 1 times 7 is 7. answer is negative 8 over 7. Okay? Alright, I can do the same thing in number 17, negative 7 divided by negative 7 over 5. Well, let's rewrite that negative 7 as negative 7 over 1. So I have negative 7 over 1, and remember, let's look back up here, dividing by a fraction, which is what's going on here, is the same as multiplying by the reciprocal. So let's multiply this by, and flip the fraction, multiplied by negative 5 over 7. And know that whenever there's a negative in front of a fraction like this, that negative can be placed on either the top or the bottom, but not both. So you would not want to make this negative 7 over negative 5 because, well, that would end up being positive. So let's see if we can reduce here. Negative 7 over 1, nope. Negative 5 over 7, nope. But I can cross reduce. Negative 7 over 7, well, I can make that a negative 1 and make that a 1. Because negative 7 over 7 is negative 1. And when I multiply across, negative 1 times negative 5 is 5, and 1 times 1 is 1. So my answer is just 5 over 1, or 5. Alright, let's apply this to some of the expression applications that we talked about back in 1.2. It says find the value of the expression x over y for the given values of x and y. So if x equals negative 5/13, I'm going to plug that in here for x. And if y equals 3/5, I'm going to plug that in there for y. So I have negative 5/13 divided by 3/5. Okay? And again, that looks kind of messy. So let's instead of dividing by the fraction, let's multiply by the reciprocal. So I'm going to have negative 5 over 13 multiplied by 5/3. Okay, and let's see if we can simplify this at all. Can I reduce 5 over 13? No. I can't cross reduce here either. 5 and 3, can't do that. Can't cross reduce there either. So I'm just going to multiply across. Negative 5 times 5 is negative 25, and 13 times 3 is 39. Alright. What happens if I have mixed fractions if I am solving mixed fractions or simplifying mixed fractions by multiplying or dividing? Well, the first things first, I don't like these mixed numbers. Let's turn them into improper fractions, okay? Or let's turn them into fractions that will be easier to do this with. So, remember from last lesson, if I want to turn this into a mixed number, I'm going to do 5 times 1, which is 5, plus 4 is 9, so I have 9/5, and then I got to add that negative in at the end. So wait until the end to add the negative in. So really I have 9/5 divided by 5 times 4 is 20, plus 1 is 21, 21/5. And again, don't multiply across yet, because this is a division sign. So remember, dividing by a fraction is the same as multiplying by the reciprocal. So I have negative 9/5 times 5 over 21. Okay? And can we reduce it all? Why, yes we can right here. The 5 and the 5 can reduce to 1 and 1. And what about 9 and 21? Can I reduce that at all? Well, both are divisible by 3, so I can make that a 3, because 9 divided by 3 is 3, and 21 divided by 3 is 7. So when I multiply across, I get, this is a negative, negative 3 times 1 is negative 3, and 1 times 7 is 7, so I get negative 3/7. Alright, lastly, number 20, I have 2 and 2/3 times 2 and 5/6. Let's convert these to improper fractions. 2 times 3 is 6, plus 2 is 8. So I have 8/3 times 2 times 6 is 12. 12 plus 5 is 17, times 17 over 6. Again, remember, this denominator matches this denominator, and this denominator matches this denominator. So, is there any place I can simplify? Can I reduce 8 over 3? No. What about 17 over 6? I can't reduce that either. But can I cross reduce? Can I reduce 17 and 3? No, 17 is a prime number, but both 8 and 6 are divisible by 2. So I can turn that 8 into a 4, and this 6 into a 3. So 8 divided by 2 is 4, 6 divided by 2 is 3, and when I multiply across, I get 4 times 17, which is 68, and 3 times 3, which is 9. So my final answer is going to be 68 over 9. Okay, so that is multiplying and dividing real numbers. Okay, please refer to this video as needed. And again, feel free to find me during the school day if you have any questions.